is special fibers, aramid fibers. Aramid fibers. What is meant by aramid fibers? The U.S. Federal Trade Commission given as a good definition of aramid fibers as a manufactured fibers in which the fiber forming substance is a long chain synthetic polyamide in which at least 85% of amide linkages are attached directly to two aromatic rings. Types of aramid fibers. There are mainly two types of aramids fibers: meta-aramid and para-aramid. The term meta and para refers to the location of chemical bonds in the structure of aramid fibers. The chemical bonds of a para-aramid fibers are more aligned in the long direction of the fibers. The meta-aramid fibers are not aligned, they are in zigzag pattern. Therefore, they are not developed the higher tensile strength of the para-amide bonds. Meta-aramid fibers made from the meta-aramid have the excellent thermal, chemical and radiation resistance and are make the fiber retardant textiles such as outerwear for firefighters and racing car drivers. Nomex and Desiconex are example of meta-aramids. Then next, going to the para-aramids. Fibers which are made from the para-aramid have higher strength. These are more commonly used in fibers, reinforcement, plastics for civil engineering structures, stress skin panels, and other highly tensile strength applications. Kelvar and Technora are example of para-aramid fibers. Early 2000 properties of aramid fibers. Different trade names of aramid fibers. Aramid fibers are available with different trade names. Their properties are determined by the manufacturing process, conditions in which fibers are prepared, and end uses. Different trade names of aramid fibers are Kevlar, Technora, Tavron, Nomex, etc. Manufacturing process of aramid fibers. The polymer polymethylene isopropylamide is used to make meta-aramids. The polymer methylene terephthalamide to make para-aramids. Because the aramids decompose before they melt, they are produced by wet and dry spinning methods. Sulfuric acid is the normal solvent used in the spinning process. In wet spinning is a strong solution of the polymer, which also contains inorganic salts, is spun through a spinneret into weak acid or water. In this bath, the salt leach out in the drying spinning process. The salts are more difficult to remove. This process is only used to produce the weaker meta-aramid fibers. In both processes, post-treatment of the fibers by additional drying is used to optimize fiber properties. Aramid products are available as filament yarn, staple fiber, or pulp. Aramid fibers manufacturing method. This is the aramid fibers manufacturing techniques. This is called as a step-by-step processing of aramid fibers. Characteristics of aramid fibers. Fiber structure. In aramid fibers, a series of synthetic polymers in which repeating units have large phenyl rings are linked together by amide groups. Amide groups form strong bonds that are resistant to solvents and heat. Phenyl rings are bulky six-sided groups of carbon and hydrogen atoms that prevent polymer chains from rotating and twisting around their chemical bonds. Fiber properties. Aramid fibers have medium to ultra high strength, medium to low elongation, and moderately high to ultra high modulus, with the densities ranging from 1.38 grams per centimeter cube. And heat resistant and flame retardant fibers contains high proportion or meta-oriented filtrin rings, whereas ultra high strength high modulus fibers contains mainly orientated filtrin rings. Chemical properties. All aramid contains amide links that are hydrophilic. However, not all aramid products absorb the same moisture. Fibers has very good resistance to many organic solvents and salts, but strong acids can cause substantial loss of strength. Aramid fibers are difficult to dye due to their height. Also, the aromatic nature of para-aramid is responsible for oxidative reactions when exposed to UV light that leads to change in color and loss of source strength. Thermal properties. Aramid fibers do not melt in conventional sense but decomposes simultaneously. They burn only with difficulty because of limited oxygen index values. It should be mentioned that at 300 degrees Celsius, some aramid types can still retain about 50% of their strength. Advantages of aramid fibers. Aramid fibers' main advantages are high strength and low weight. Like graphite, it has slightly negative axial coefficient of thermal expansion, which means aramid limitations can be made thermally stable in dimensions. Unlike graphite, it is very resistant to impact and abrasion damage. Disadvantages. On the other hand, aramid fibers have few disadvantages. The fibers absorb moisture, so aramid composites are more sensitive to the environment than glass or graphite composites. For these reasons, it must be combined with moisture resistance materials like epoxy systems. Compressive properties are relatively poor too. Consequently, aramid fibers is not used in bridge building wherever king is resistance is needed. Applications. Ballistic protective applications, bulletproof vests, protective apparel such as gloves, motorcycle protectives, sails for sailboats, belts and hosting, industrial automatic applications, aircraft, boat hulls, fiber optic. Conclusion. The current production of continuously to 6,000 metric tons that represents 40,000 meters per year. The development of pararamid fibers has been slowed down by certain disadvantages that have turned up gradually with their use. These advantages include poor compression strength. Thank you.